Okay, so let's do in class number 3, question 1. It says, first sketch the curve represented by the vector function r of t equal to 2 cosine ti 2 sine tj plus 4tk on 0 to pi. Then find a r of t dotted with r prime of t and b r of t cross r prime of t. Okay, so let's make a little table so we can graph our vector value function. Okay, so putting 0 in place of t in our vector value function here. So it's going to be 2 cosine 0 sine of 0 j plus 4 times 0 k. Cosine of 0 is 1, so it's going to be 2. Sine of 0 is 0, so 0, 0. There's a point. So when t is 0, we have 2, 0, 0. Let's next do pi over 4 for t. Okay, so putting pi over 4 in place of t up here, so it'll be 2 cosine pi over 4 I plus 2 sine pi over 4 j plus 4 times pi over 4. The cosine of pi over 4 is square root of 2 over 2. The 2's will cross off if you just get square root of 2. Sine of pi over 4 is also square root of 2 over 2. So it'll be square root of 2 here, and the 4's cancel here, which is pi. Let's next go, so we're going to go by increments of pi over 4. So next one will be 2 pi over 4 or pi over 2. So let me do that one next. So putting pi over 2 in place of t will be 2 cosine pi over 2i, 2 sine pi over 2j, 4 times pi over 2. So then cosine of pi over 2 is 0. It's going to be 0 here. Sine of pi over 2 is 1. It's going to be 2 here. And this will become 2 pi here. So I'm going to keep going by increments of pi over 4 all the way until I get to 2 pi. So let me write out the answers I'll get here. Okay, so plugging into the points. So 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. Let you check, you get these answers. Okay, so now let's start graphing our vector value function. So just looking up here, here's a vector value function here. It has 2 cosine I, 2 sine j, and 4tk. That means in the xy, it's going around a circle of radius 2. And so pretty much it's going to be wrapping around, it's going to be helix, it's going to be wrapping around a circle of radius 2 centered at the origin. So let me do a picture over here. Okay, so we're drawing a cylinder here. So the circles here are centered at 0, 0, and say they have radius 2, so that's going to be 2 units there. Okay, so let's start plotting the points. Let's do 2, 0, 0 now. So my x-axis is this way, my y-axis is this way, my z-axis is this way. Okay, so let's plot 2, 0, 0. So it'll be right here, because 2 on the x, 0 on the y, 0 on the z. Let's do now square root of 2 pi next. Okay, so the square root of 2, square root of 2, so square root of 2 on the x, square root of 2 on the y, will put you at 45 degrees in here. Okay, and then it's up at pi, so each of the tick marks is representing pi, so that'd be pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, because 8 pi is the largest one we have over here. Okay, so it's at square root of 2, which is here, then up pi, which will put me right here. That's my point. Okay, let's do now 0 to 2 pi. So it'll put me right here, because it'll be 2 on the y, then up 2 pi on the z, so it'll be right here. Again, each tick mark is a pi, so it's 2 pi right there. Alright, let's do next the negative square root of 2, 3 pi. Okay, so that's putting me up here, because it'll be negative square root of 2, over here. Then up square root 2 on the y, so it's at 45 degrees again here. Then up 3 pi, so 1, 2, 3, so dot right here. Okay, let's next do negative 2, 0, 4 pi. So that put me here then. Let's do negative square root 2, 5 pi. So put me here then, because we're at negative square root 2 would put me down over here. Then up 5 pi, 1, 2, 3, 4, 5. Think about here. Okay, let's do now 0 minus 2, 6 pi. So it put me here. So we're at a negative 2 on the y, so it'd be here. Then 6 pi on the z, which will put me here. Okay, let's do now square root of 2, negative square root of 2, 7 pi. So it put me here. So it'd be negative, square root of 2 on the x, negative square root of 2 on the y, and then 7 pi on the z. And lastly, let's look at 208 pi. Okay, that put me up here. Okay, now let's draw the curve. Okay, connecting our points, we get a helix. I removed the other dotted lines in there so I could see the graph better. So this is what the graph should look like, our curve. So it's a helix wrapping around the cylinder. Okay, now let's go on and do part A of the question. So I'm going to erase this now. Okay, so let's do part A. We have to do RT dotted with R prime T. Here's my R up here. So let's do R prime. So R prime would be derivative cosine, which would be minus sine, derivative sine, which would be cosine, derivative 4t, which would be 4. So let me write that here. Okay, so here's my R prime. So again, derivative cosine to be minus sine, derivative sine to be cosine, derivative 4t would be 4. Now let's dot our R prime with the R, so it'll be 2 cosine times minus 2 sine, so it'll be minus 4 sine cosine. That'll be 2 sine t times 2 cosine t, so it'll be 4 cosine sine, and 4t times 4 will be 16t. So let me write the answer here. So dotting, I guess, we get this. So again, it's going to be 2 cosine times minus 2 sine. It'll be negative 4 sine cosine for the I component. Then multiplying the j components, be 4 cosine sine, and then multiplying k components, 4t times 4 will be 16t. Now these two will cancel. So it's going to be 16t as our answer. Okay, let's do now part B here. So let's look at the cross product now. Let me write it over here. Okay, so here's my cross product definition. So I have my RT on the second row here. Got the IJK first row, so RT second row, and the R prime guy. So R prime's up here on the third row. So let's do the cross product. So we'll do the I component first. So it'll be 2 sine t times 4 minus 4t times cosine of t. That'll be the I component. Let me write it here. So we get this then. So it'll be then, again, 2 times 4 will be 8 sine, then minus 4t times 2 cosine will be 8t cosine. That'll be I component. Let's do j next. So j is going to have a minus sign in front, and it's going to be 2 cosine t times 4, and then minus 4t times minus 2 sine t. Let me write that here. So we get this. So again, it'll be 2 cosine times 4 will be 8 cosine. Then it'll be minus 4t times minus 2 sine t, so it'll be minus 8, sorry, it should be t here. 8 t sine t. Let's do the k component next. So k component would be 2 cosine times 2 cosine minus 2 sine t times minus 2 sine t. Let me write that here. Okay, then we get then, we can pull 4 out of these, and you can check it's just going to be cosine squared plus sine squared. Because you'll have a 2 sine, you'll have minus 2 sine times minus 2 sine here. That's how we get the sine squared here also. So this is going to be 1 right here, the cosine squared plus sine squared. So let me write the simplified answer down here. So we get this. So in the I component, I just pulled an 8 out up here. So that's how I got the 8 in front here. And then here I pulled an 8 out also. So it'll be minus 8 in front then. And 2 minus will make a plus there. So it'll be negative 8. Then cosine plus t sine. And again, cosine squared plus sine squared is 1. So we're just going to get a 4 in the k position here. So this is our answer here. Okay, so we're done with the question. I'm going to stop the video here and do the question 2 in the next video.